This is our ECET Senior Design 2011. Luke Schmude, Steve Pope, and Trevor Hunter. Our economics advisor is Roger Kuntz. This was done for process and data automation. We're just going to go through a quick thing of our screens and some system operation. Here's our PID loop tuning screen. You can see the tower tank and its gallons in the tank. We have in our upper left-hand corner our set point and pump number, and our upper right our start and stop buttons. Now we have our trend graph. This just kind of gives you a preview of how the system is responding. We have our PI and D values for the pumps on the left, along with our set point and tower level. So our lead lag screen, we're in auto mode there. Now we're going to go back to manual mode. You can see that we just enter your pump duty in the bottom and the lower and right hand corners. Here we have our configuration screen. This is where you get to enter your PI and D values as well. Up on the top, you can see your pump usage screens, hours and minutes on the pumps. And then we have our alarm history screen. This just kind of keeps track of everything that's gone wrong, fault-wise, in the system. And now we're going to go to PID tuning screen. We can see we have a set point set for 50 gallons. We're using pump number 2, and we have 40 gallons in the tank at the moment. And we'll start the pump.
This is the physical system of the senior design project that we built, the plumbing and the electrical side of things, and the pumps over there and our enclosure over there. On top of our 480 volt enclosure, we have the stack line indicating the state of the system, which is currently green for go. And this is, you can see the water level right now is at 45 gallons, which started at 40 gallons. So right now we're just letting it ramp up to the 50 gallon set point. This drain valve, it acts as a limit of how much water is able to escape from the tower tank into the reserve tank. And then from the reserve tank, we have the hand valve leading to the pumps going up through these three pipes here, which act as the to test the PID loop effectiveness. We can limit it using these 3 hand valves that goes into the tower tank to set the level. Once it reaches this 50 gallon tank that's going to reach in a minute, we're going to limit the flow in from this 1 inch valve or 1 inch pipe to 3/4 and then 1/2 inch to see at the smallest flow rate if it's still able to keep that set point from our given PI and D values. As you can see, it's reached 50 gallons now, so I'm going to close the 1 inch valve and see how it reacts. To compensate for that, it simply increases the duty percentage of the pumps pumping into the tower tank. So it seems to be keeping that pretty well, so now we'll go down to the 1/2 inch size. So now the water is only flowing through this 1/2 inch pipe up into the 1 inch into the tower tank, so the pumps speed up. Currently we have them limited to 75% duty, but as to not damage the pumps, we just want them maximum running 75% of their full 60 hertz. So that'd be 45 hertz as it's currently running at to keep up with this set point going through such a small pipe. As you can see, it's pretty steady. Our PI and D values are pretty accurate as to hold the set point right at 50 like we wanted. And in case of any emergency in the system, what either Luke, Trevor, or myself would do is come over to the emergency stop button, press that, immediately see that the red and blue stack light come on, and the pump stops. So that just shows that there's something wrong, so the system will stop. Normally there's a horn in there, but due to the loud nature of the horn, we don't want to disrupt any employees here at Process and Data Automation, so we put in a blue light.